wonderful to be here. It's an honor to be back in Munich at the Carson Center. Thank you all for tuning in, coming out and talking about fish. And I want to thank Christoph and Helmuth and Ariel and everyone who is part of the Rachel Carson Center community. This is such a wonderful place to be able to come and do research. So I'm interested in the politics around fish. So you might think that what's important where fish are concerned is the ability to catch them, but more important than that is that fish are a territorial claim and always have been during history. And that has ramifications for us today, and that's what I'm going to be looking at. That's right, I can't move around. Okay. I want to begin by kind of a recall to some prior lectures. Ron Dole, a few weeks ago, told us about how the Soviets were so far ahead of the Americans when it came to earth sciences in 1945. And the Japanese were also far ahead of the Americans when it came to oceanography and fisheries science in 1945. Miles Powell told us about sharks, a very ancient fish, and one of the problems with sharks is that they have very low fecundity. So when they're overfished, it's very difficult for shark stocks to reproduce and recover. And my fish are completely different from Miles, so I'm going to talk about that. I unfortunately can't link to sea ice in the talk last week with Nina Worms because my fish don't deal with sea ice. These are warm water fish that endlessly swim through the warmer waters kind of at the top of the Pacific. Some 70% of tuna stocks live in the Pacific, and they are a warm water fish. They're frequently warmer than the water in which they swim. And they swim very fast. They can swim some 40 miles an hour. And it was a long time before fishermen were able to catch a lot of tuna because they couldn't catch them. And so that's kind of one of the key things about their biology. But let me talk a little bit. I'm going to make 3 points today: that their unique biology shaped recruitment fisheries oceanography, and that's a subfield of oceanography that integrates kind of atmospheric science, meteorology, oceanography, and fisheries. It's a subfield. I'm contending that the Japanese contribution to the science has been overlooked. And the third point that I want to make is that the construction of the science, I think, constituted a territorial claim. And I'll talk about that a little bit more. As I mentioned, they swim very fast. It took a long time for boats to have engines so that they could catch up to the fish. The Japanese pioneered the fishing for tuna using these slender bamboo poles with hooks on the end. And the way that they would get the fish to slow down was that they would throw live bait in the water. And tuna are able to go for long periods of time without eating. And then when they encounter bait, they go into a feeding frenzy. And they would snap at these bear hooks, and fishermen would be able, 2-3 fishermen on a pole, would be able to haul them into the boats. So the beginnings of industrial fishing on tuna don't really happen until the 1940s. So I'm going to talk a little bit, wanted to kind of situate my talk. I hope I can figure out where Japan is up here. Not the greatest map. So Japan's kind of up there. But I'm going to be talking about this area in here. And today we would call this Micronesia, but in the 1940s it was known as the Mandated Islands, the Marshall, the Mariana, and the Caroline Islands, and the Gilbert Islands. And Japan had a mandate from the League of Nations at the end of World War II to develop this area. So they're known as the mandated islands. And in the 1930s, the Japanese developed a lucrative fishery for albacore in these waters. So that's the geographical context. I did say that these were, today we call these the Micronesian islands. Okay, I wanted to make sure that I made that point. The political context, because I contend that the political context shapes the science, and not always to the advantage of fish stocks. So there are kind of three significant events here. 1944, the American Congress passes a bill. They want to expand fishing deeper into the Pacific. And it's aimed squarely at the Japanese, because the Japanese have developed a fishery for king crab in Bristol Bay, Gulf of Alaska, and for tuna deep in the Pacific. A bill that passes in 1949 sets up a laboratory in Honolulu, and it funds 3 research ships. And there's a plan that the Japanese are going to, or the Americans rather, are going to replace the Japanese boats that have been fishing tuna in the mandated islands. And this is a really ambitious scheme, because the Americans have only made it as far as Hawaii, so they haven't been able to get that further distance into the Eastern Pacific. So it was a very grandiose plan. And the idea was that if they could get American fishing boats in this area where they've established military bases, they're about to begin nuclear testing. So if you could sprinkle some American fishing boats in those waters, it would kind of normalize the American possession of the territory. So that's the political context. The Japanese pioneered the catching of tuna with those long, slender bamboo poles, but they also pioneered the science around tuna. And Kishinue began the study of tuna in 1911, and he published in 1923 in the Journal of the Imperial University of Tokyo, I think that it was, and for a long time, 20, 30 years, this was the most information that had been pulled together about tuna stocks. And it's available on the internet. You can download it. The first time I encountered it, it was in the library at Oregon State University, and it had these beautiful fold-out pictures of the vascular system of the tuna. And unfortunately, I couldn't get them all downloaded for this presentation. But he begins, as I say, he's the benchmark for what's known about tuna. But the question that eludes him is where the fish spawned. And that's really important, because if you're going to try to find them, it's good to have a starting point. You don't want your fishing fleet wandering around the Pacific hoping that they are going to encounter some fish, because that's wasting money. So this was a goal of the science for a long time, was to figure out where did they spawn so they could more precisely target catching them. So, as I said, the Japanese had a fishery in the mandated islands in the 1930s. The war ends. The Americans have taken possession of all of this area in the Pacific. And this isn't a really good map, but basically, oops, sorry about that. Okay, my point is that the Japanese fleet is maintained in its home waters, tightly controlled where they can go. They can't move into Soviet waters. They can't expand into the China Sea. They are tightly contained in the waters around the islands. And that's expanded a couple of times in 1946 and 1950. But basically, the fleet is contained. And one of the great successes of the American occupation during the war was the rapid rebuilding of the Japanese fishing fleet. And unfortunately, it's relatively easy to build fishing boats. It's not necessarily easy to figure out what to do with them once they've been built. So there was a lot of pent-up demand to get a peace treaty so that the boats could get out of the MacArthur zone, as it was called, and start resuming the fishing activities that they had had before the war in the wider Pacific. But it's while the Japanese fleet is buttoned up that the Americans see this opportunity to establish their own fishery in these waters and their own territorial claim. So the Pacific Oceanic Fisheries Investigation is set up as a result of the Farrington Bill that I mentioned earlier. And this is really significant legislation because it returns American oceanographers to the ocean. So the U.S. Fish and Wildlife through the 1930s had faced budget cuts, and they were not doing research at sea. So this was really significant that there was $1 million in 1949 to open the new laboratory in Honolulu, and then there would be 3 ships that would be doing ocean research. And the idea was that they would investigate for new species of fish. There were actually 4 fishery investigative units set up. One's based in Seattle, one in the Gulf of Mexico, one in the Atlantic. And the director of this one is the gentleman in the center here, Elton Setti. So very significant piece of legislation. But so the idea was that the Japanese fleet is all bottled up, the ocean is wide open, and the American boats are going to go out and find tuna. And the only problem with this is that they really didn't know anything about tuna. They knew even less than the Japanese knew, and the Japanese didn't know anything about the migration routes and finding them. So what the Americans come up with is the Japanese reconnaissance team. That's part of the Pacific Oceanic Fisheries Investigation. And this consists of 3 American fisheries scientists who go to Japan with the objective of obtaining Japanese scientific documents and translating them to hopefully facilitate the American takeover of the Japanese fisheries in the mandated islands. And the most significant person in the reconnaissance team is a Japanese-American scientist named Bell Shamada, and he's here, I guess it's the left. And he's got a really interesting story. Japanese-American, he entered the School of Fisheries at the University of Washington in 1937, and he was a senior in 1941 when war was declared, and he was interned, like thousands of other Japanese Americans who were sent to an internment camp. He volunteered for infantry training. He was selected for language and intelligence training. And he spent the war he was in Hawaii, he was in Guam, and then by the end of the war, he is in Tokyo. And he is working with the military occupation, dealing with the impact of American bombs on kind of Japanese territory. And with the passing, he comes home from Tokyo. He goes back to school in 1947. He finished his degree, and then in 1949 he finds himself back in Tokyo as well as part of this reconnaissance team seeking information about Japanese fisheries. And he kept a journal. It's really pretty brief. It's typed on lined paper, and his family shared it with me. And it's just a really interesting document. There is not a personal word in it. It's a total scientific document. Who he's been talking to, documents that he's able to get a copy of. He's taking samples from the fish markets. He's trying to figure out, where the albacore have been caught, what depth have they been caught at, what's the salinity, what's the temperature. All of this information is poured in his relatively brief journal. And one of the big questions that I have about the journal is, how was he received by these Japanese researchers? Were they flattered that this American wanted their science, or did they resent that the Americans were taking their science and what they were going to do with it? It's just if I was a novelist, I think that this would be a wonderful topic to look at, the interactions between Bell and the Japanese science community at this time. And he's supposed to stay there for 3 months. He ends up staying for 14 months, and just a significant amount of material passes through his hands and into Pofi. And one of them is the minutes from a meeting that Japanese scientists held in 1940 in Palau. And Kamakushi had just died. He'd been on an expedition to China the year before. And all of the Japanese researchers on tuna came together at this meeting to pool their knowledge and to come up with a research plan so that they could figure out where the fish spawned, that would be the key to increasing the catch. And Bell was able to find the report on this, and he and one of the other translators, there were half a dozen translators at SCAP, they were able to translate this and publish it in the United States. So all of this information is pouring into Honolulu. There's Bell's reports. The 3 ships have launched, and there's scientists on board, and they're doing cruises out of Honolulu, and there's all of this data on temperature, salinity, weather, catches. All of this information is pouring into Honolulu. And it's synthesized, there are no computers, right? So all of this information is, and all of the translations, or at least a lot of the translations are coming into Honolulu. And the result is a report that's published in 1954. The primary author was Dr. Seti. And this lays out the basis for recruitment, fisheries, oceanography, and again, the integration of these 3 fields into applied to the catching of tuna. And one of the things that they come up with is the first construction of why tropical waters are so productive, and it has to do with the steady trade winds stimulating upwelling so that nutrients from the bottom of the ocean come upward, are stimulated by the sunlight, and the result is a strong food chain, and tuna are at the top of that food chain. So this is one of the significant things that emerges from this research. So the document is just really interesting. It's only about 80 pages. There's 50 pages of text. And then there's some 30 pages of footnotes, and probably, I guess at least a third of the footnotes are translated from the Japanese. So on the one hand, we have the Japanese science is acknowledged in this very critical report, but it's also really, at the same time, it's masked, right? Because it's rolled into American science, and it's published by the Americans, and there's not really any clear acknowledgement of what the American scientists owed to their Japanese counterparts. So I contend, as I said earlier, that the role of the Japanese in the development of this science, I think, has not really been as acknowledged as it should be. So while we have Gotta stand still. So while we have the Americans running around vacuuming up everything that they can find on tuna and ocean conditions, but also on salmon and on hatcheries, all of this information being translated and stored. And at the same time, the Japanese science is also being denigrated. And the Supreme Commander, Allied Powers, the occupation, brought teams of lots of American scientists to come to Japan and to kind of evaluate what SCAP was doing. And a team of visiting experts from American universities that was headed by a scientist from Stanford University. And they wrote a 50-page report that lauded SCAP for the work that they were doing, but also denigrated the Japanese science. They said that they were not doing population studies, that the Americans were doing population studies, and that the Japanese were focused on the technology for finding fish, and that this is not science, this is technology. And the ironic thing about this criticism is that Pacific Oceanic Fisheries Investigation and their 3 vessels are set up to find technology, find fish, and to figure out the technology in order to catch them. So it's an interesting document in a number of ways for what it says, but also for what it doesn't say. So, did I miss anything there? No, okay. So the result of finally figuring out where the fish spawn and being able to follow them resulted in an enormous expansion of the catch of tuna. And there are a number of other things that go into this. The technology develops. Tuna fishing with nets used to require a very large crew to pull the net in, but with the development of hydraulic motors and nylon nets, it was possible to fish with a much smaller crew and to fish much more efficiently. So we have, enormous technological developments that stimulate the expansion of fishing in this fish during this period. And then we also have, in the 1960s and 70s, the development of superfast freezing, which means that the fish can be caught anywhere in the world, processed at sea, and then delivered anywhere else in the ocean. So one of the things that is so interesting that the Japanese fleet goes from being contained in the MacArthur zone and not being allowed to fish, and then when the treaty is signed, when the peace treaty is signed with Japan, and the peace treaty with Japan is almost held up over questions of fish and where Japanese boats are going to be able to fish for salmon in the North Pacific. So fish are really at the center of a lot of politics in the Pacific. So the Japanese are able to rebound with this technology and to dominate the catch of tuna during this period. So this is an old graph. It only goes up to 1980. There are new entrants fishing for tuna now. The Japanese don't dominate to quite that extent. South Korea, Taiwan. There are other boats that have entered the fishery since this period. And from that, I'm going to make a leap to what's going on today and to a report that the World Bank put out in 2017. And it pointed out that the tuna are the most significant natural resource that the Micronesian islands have. And yet somehow with the development of tuna fisheries, there's very little benefit that comes back to the islands, that most of the fish is, tuna is an industry worth $3.4 billion, and only about a third of that revenue comes back to the islands in which the fish are caught. And the World Bank issued this report in 1917, kind of raising the question of what is the future of the islands going to be, and how can they recover more of the value of the fish that are caught in their waters. And this 1917 report is really strengthened by another report that the World Bank issued a couple of weeks ago, a companion to the Glasgow meeting on climate change, raising the questions about the future, particularly in the Marshall Islands, where climate change is causing rapid inundation of the land. So these two reports are really linked. The tuna, the question of the ability of the islanders to access more of the value of tuna, and then their very existence is threatened by these rising waters. So what I'm contending is that the science, this co-construction of the science here, during the early 1950s resulted in the science being used as a territorial claim on the fish, principally by Japan and the United States, but by other nations as well. And the result has been that the island people derive very little benefit from the fish in their waters. So that's the claim that I'm making in this work that I'm doing now. I'd like to thank the various people, particularly the Shamada family, for their access to Bell's papers. And I also wanted to say that there is more about all of this on my blog, the Pacific Fishery History Project. I've got something like 150 different blog posts by me and by several others looking at the development primarily of fisheries in the Pacific. A lot of people focus on development in the Atlantic, but fisheries developed in the Atlantic over hundreds of years, whereas development in the Pacific was really rapid, partly because of technology transfer, information transfer, kind of government programs, and again, the political objectives around the catching of tuna. When you're talking about fish, it's never just about the fish. There's always another agenda. So thank you very much.